Hello world, welcome to my channel. My name is Sarvanan Nadar. In this video we are going to learn what is sampling distribution and the different properties stated by central limit theory by sampling distribution. To draw a sampling distribution, we first need to get the means of all different possible samples of a fixed size n from our population and draw a graph out of it. The resulting graph that is known as sampling distribution. And let's take an example to understand the central limit theory. If I have a population containing of heights of students and its mean is 5 inch, and we have a sample of heights from this population. Each sample's mean, let's say it has 4 inch, 5 inch, 6 inch, 3 inch. Then if we want to calculate the standard error, that is how our means differ from population and as that of collected sample mean. To solve this, first we need to find the average of the heights calculated out of the samples. Then we need to find a standard error. That is how much what is the standard deviation of sample mean. We can calculate the variance of sample statistic data set and then the standard deviation out of it, or either we have a shortcut here, that is you can divide the standard deviation of population divided by square root of our sample size, which is the standard deviation of sample mean and is also known as standard error of the sample. So now to get the number of standard errors away from the mean, our observation is we can use the ZScore formula, that is a statistic mean which we have calculated, subtract the mean as that of the population divided by the standard error that we have calculated. So you know that we are relatively close to that of the population distribution. Okay, the central limit theory which we can observe in here is that the mean of the sample mean is approximately same as that of the population mean. And as the sample mean size, that is n, increases, the sample mean would be equal to as that of the population mean, and the standard deviation of the sample means is always equal to that of the standard error. That is a shortcut formula that we have used, that is standard deviation of population divided by the square root of sample size gives us the standard error. And the next observation is that the distribution of sample means will become increasingly more normal as the sample size n increases. That's it for now, guys. If you like this video, don't forget to put a like and subscribe for more videos. Bye for now.